Here, a giant cell makes its way and breaks down bone tissue. In a year, over 10% of our bone mass undergoes remodeling, and for good reason. The continuous processes of resorption and formation ensure healthy and stable bones. Bone remodeling repairs minor damage and prevents future issues by replacing fatigued sections with fresh bone tissue. Our bones also adapt to stress. For example, strength training stimulates tissue formation, whereas a lack of activity promotes degradation. Bones are therefore not rigid structures and are far more complex than is often assumed. Let's take a quick look at the femur. Apart from the joint surfaces, the femur is covered by a thin layer of connective tissue. The periosteum is well supplied with blood and contains nerve fibers and the stem cells that are essential for bone regeneration. Although not visible here, the inner surface is also covered by a skin. The compacta bears the main load on the bone. Inside, we see a spongy tissue called the spongiosa. In adults, the medullary cavity contains the yellow bone marrow, which, unlike red bone marrow, does not produce blood cells. Due to its large surface area, the cancellous bone is predestined for a high bone turnover. This is where the so-called houseship lacunae can be found. They are the result of the activity of bone-eating osteoclasts. Once they have identified an area to be repaired, they attach and create an acidic environment between themselves and the bone. The mineral crystals stored in the bone then dissolve. Calcium and phosphate are released. Special enzymes are secreted by the osteoclasts to dissolve the protein matrix, which mainly consists of type 1 collagen. The osteoblasts are responsible for the formation of new bone tissue. They produce osteoid, which is the new, non-mineralized base substance. Some osteoblasts remain in the osteoid and develop into osteocytes. The osteocytes connect with other cells of their type through long cell projections and form a network. This network responds to stress and plays a crucial role in orchestrating bone remodeling. Over time, the osteoid mineralizes and new stable bone tissue is formed.